So the last video we discussed was a little drawing kind of showing the same thing as you see here. Again, I highly stress the importance of making sure you know and understand what this drawing is and what it means. So epinephrine and norepinephrine are both used in our body and both can be used clinically. They have different roles depending on where they're located and what type of receptors they are. So this is kind of showing that same thing again. This is in a little bit more detail. I don't care that you know all the specific detail, like you don't need to know what D or D1 is here. But this is just kind of showing the same thing in a different picture. If you remember, we talked about adrenergic receptors and how there's an alpha and a beta subtype. So this is really important with medications. So medications called beta blockers, you'll know because they end in a lol. Decrease heart rate and force of contraction. Examples, propranolol, metoprolol. These are both very common. Propranolol is also used in migraine treatment through a different mechanism. And then alpha blockers work more on lowering blood pressure. Reserpine is an adrenergic blocking medication, and it blocks the synthesis and storage of norepinephrine. So if you block norepinephrine, you block sympathetic nervous system activity, which leads to parasympathetic effects, like the rest and digest. So increased digestion, urination, and then this is used as a tranquilizer because it makes an individual feel very, very sleepy. So which autonomic division uses muscarinic receptors? And if a patient were poisoned with muscarine that binds the muscarinic receptors, what would be some symptoms? So pause, think about it, and then move on to the answers. So the parasympathetic division uses muscarinic receptors. If someone were poisoned with muscarine that activates these receptors, we would get parasympathetic response. So increased salivation, increased activity in the stomach, so increased digestion. But what that might look like with poison is vomiting, potentially diarrhea as well. And then decrease in heart rate and blood pressure, and then other responses might also be noted. A cholinergic inhibitor, two examples, atropine and scopolamine, they both block acetylcholine on muscarinic receptors. They do nothing to nicotinic receptors. So this causes kind of a sympathetic nervous system activation. So you see the pupils are dilated, we get decreased digestion. So this can control diarrhea from food poisoning. And then it can be used as with other indications as well. Which neural system uses nicotinic receptors, and what would happen to a patient who received a nicotinic blocker instead of a muscarinic blocker? Pause, think about it, and then we'll go through the answers. So this was kind of a trick question, right? The neural system that uses nicotinic receptors? It's all of them. So sympathetic, parasympathetic, and somatic motor, which is your skeletal muscle. So if we blocked nicotine receptors, instead of giving them a muscarinic blocker, they would become paralyzed. So they would block movement. So I have one slide on something that deserves kind of its whole own class. But this is the enteric nervous system. So this is the nervous system of the digestive tract. There are at least 100 million neurons in the digestive tract. So not in the central nervous system, in the digestive system. It has its own reflexes, and this system is able to regulate your motility, so the movement and the digestion, kind of working with the ANS, the autonomic nervous system. The enteric nervous system is kind of new, and we're still figuring this all out. But if you've heard about like gut health and like all these like trendy new ideas, and they come from this research showing that we kind of have our own brain in our gut. But yeah, I'm just gonna leave it at that. And if you guys are interested in that, definitely look more into it. So here's a little compare and contrast. Somatic motor, these are muscles, and then an autonomic nervous system. So pause, fill out this chart, and then we'll go through the answers. So the effectors in somatic motor are muscles. In autonomic nervous system, everything else. So smooth muscle, cardiac muscle, any glands. The origin, spinal cord, autonomic nervous system, spinal cord or brainstem. Number of neurons, number of fibers in chain, 1 versus 2. Is it myelinated? Always yes in muscle. In autonomic nervous system, preganglionic yes, postganglionic no. Excitatory, skeletal muscle always. And then in autonomic nervous system, it can be either excitatory or inhibitory. Compare and contrast these two. Same thing, muscle versus autonomic nervous system. Pause, fill it out. We'll go through the answers. So neurotransmitter used in muscles, acetylcholine. In autonomic nervous system, acetylcholine or norepinephrine. Are there ganglia? No, not in muscles, but yes in autonomic nervous system. Voluntary, muscles always yes. Autonomic nervous system, no, usually no. You're not able to, on command, change your heart rate, change your blood pressure. If you can, that's pretty cool. Let me know.